Hey everyone, welcome to another episode in Physics is Fun. Today is going to cover more vectors and components. Let's jump into reading the question. A Tesla traverses four successive displacements represented by the expression negative 6.3 b times I hat minus 4b times cosine of 40 degrees I hat minus 4b times sine of 40 degrees j hat plus 3b times cosine of 50 degrees I hat minus 3b times sine of 50 degrees j hat minus 5b times j hat. B represents one city block. I hat is east and j hat is north. Part A, draw a map of the travel. Part B, what total distance did it travel? Part C, compute the magnitude and direction of the total displacement. One last thing to note with our I hat and j hat, if we make them negative, the direction changes, so negative I hat is west and negative j hat is south. Before moving on to draw a picture, let's write out the equations for cosine of theta equals adjacent over hypotenuse, and sine of theta equals opposite over hypotenuse. To draw, start out with a starting point. Now we just need to follow the expression given. So we have a negative 6.3 I hat, so let's go 6.3 blocks west from our start. Next we have I hat with a cosine, and should note that this is a vector component as cosine will give the x component. I'm going to group the vector components together here, grouping the similar cosine and sines together. Now we have our next vector. Following the expression, I'm going to dash out negative I hat, the x component west, and then dash out negative j hat, the y component south. With the x and y components, we can see the next vector we need. Looking at cosine of 40 degrees, which is adjacent, and sine of 40 degrees is opposite, the vector and angle must go here to satisfy that. Now mark the 4 blocks it goes at this 40-degree angle. Following the next term, dash out the I hat to the east, and dash out negative j hat to the south. Again, we have what we need for the next vector, looking at cosine of 50 degrees, which is adjacent, and sine of 50 degrees, which is opposite. The vector and angle go here to satisfy the expression. Mark the 50 degrees and 3 blocks. Last part of the expression, the vector just goes down south, and mark for 5 blocks. The drawing and part A is complete. Let's move on to part B. What total distance did it travel? To get the total distance, we just need to add each vector blocks. So we have 6.3 blocks plus 4 blocks plus 3 blocks plus 5 blocks, which equals to a distance of 18.3 blocks. Part B is 18.3 blocks. Part C asks to compute the magnitude and direction of total displacement. So we are looking for the resultant vector from start to finish. It's time to calculate. To start, let's rewrite the expression, grouping the I hat terms and j hat terms together now. This gives negative 6.3 minus 4b times cosine of 40 degrees plus 3b cosine of 50 degrees. I hat plus all of negative 4b times sine of 40 degrees minus 3b times sine of 50 degrees minus 5b j hat. Now multiplying out the angles, we get negative 6.3b minus 3.06b plus 1.928b. I hat plus negative 2.57b minus 2.298b minus 5b j hat. Now combining the I hat terms and j hat terms to get negative 7.432 blocks I hat plus negative 9.868 blocks j hat. This is the vector component form, so now let's find the magnitude and direction. Remembering the vector resultant is equal to the square root of our I hat term squared plus j hat term squared. Plugging that in now, we get r equals square root of negative 7.432b squared plus negative 9.868b squared. Then we get square root of 55.2 plus 97.37, which equals square root of 152.57, which finally equals our magnitude of 12.35 blocks. Now to find the angle of our direction for the vector, we need to set tan of theta to get opposite over adjacent, or y over x, or j hat over I hat. Solving for theta equals tan inverse of j hat over I hat. Plugging in now for j hat and I hat, we get tan inverse of negative 9.868 divided by negative 7.432. The negatives become positive, and calculating this, we get an angle of 53 degrees. So our final answer for C is going to be 12.35 blocks at 53 degrees south of west, or 12.35 blocks at 233 degrees from the start. We have solved all the parts to the question, getting a final vector displacement of 12.35 blocks at 53 degrees south of west. I hope these intro problems are as helpful for you as they are for me. Thanks so much for watching. Hope you come back to learn more exciting material, and see you next time.